stationary, and then the third one acts as a robotic arm, and then it can move, walk around.
Yeah.
Kind of the whole concept is that they're standardized, so you can put them everywhere. The other thing is that they scale, and so like the versions on this box are passives. They don't have any motor inside. They just sit there acting as a hook. But then the one on the end of this arm is active, so it has a motor on the inside. And as long as one of them is active, then you're able to make that connection. You could have two active, and that would double the mechanical force load that it's rated to. But you can kind of scale up based off what your application is. Another thing that you can do is there's room on these for pipe connections. So you can have fluid transfer. So you can do refueling or heat transfer, anything like that.
Fantastic.
So depending on what your needs are, they can kind of scale up or down what you need.
In use at the moment?
No, I think their goal is to fly it next year.
To ISS?
I'm not sure where.
Okay. Cool. Well, kind of makes sense, wouldn't it?
Yeah.
But I mean, there's been so much talk here about build on orbit and reducing basically the size and weight of the payload that you need to launch. This technology, once it was on orbit, would be extremely valuable.
Yeah, both for the active construction and also just modular design. Designing something in all these different boxes and then just piece them together like a puzzle. And then you've got the mechanical, electrical, and fluid interfaces between them.
Yeah. And it doesn't look like it's particularly heavy, the interface itself in its own right.
No, it's very lightweight, very simple. And all the control, I mean, it's just one motor in there that does one motion that goes through the entire connection sequence.
Wow.
Yeah.
So it's robust?
Yeah, it's robust, it's simple. It's a mechanical-centric design.
Fantastic. Thank you very much.
Of course.